As I mentioned, when a transverse wave travels in one direction along a string or along this wave machine, it gets reflected. The two waves, the one traveling and the one reflected, are actually interfering with one another and generate the so-called standing wave. What's a standing wave? Well, I have a standing wave here, much better than the one I could ever obtain myself because I'm always off frequency. I cannot move regularly enough to generate a perfect standing wave. A frequency generator instead can do just that, much better than me, and generate a so-called standing wave on this string that's vibrating. So this wave is traveling at 21 Hertz frequency, traveling towards the end of the string and coming back. And the waves going and coming, many times are interfering with each other, so that where they interfere constructively, they form a belly. That's a maximum of motion of this string up and down, string up and down, string up and down. These are three bellies. And destructively interfering at a node where the string doesn't move at all. There's no motion and nodes. That's another node for you. And if I point at them, you have a node at the end of the string, another node, another node, another node here. There's actually a frequency generator here moving slightly, but that doesn't matter. This is a belly, a belly, a belly. So what frequency does this particular standing wave have? Many different standing waves have different frequencies. Each one is called a mode. This is the third mode of this particular string setup with a certain linear mass density, with a certain tension, with a certain frequency. This is the third mode. Three bellies, or three antinodes as they are called, but I much prefer to call them bellies because it's much simpler. Three bellies, third mode. So if I go to the fundamental frequency, which for this particular string is 7 Hertz, we can see that there's only one belly. And you can hardly see vibrating and making standing waves now, but you have the maximum amplitude once I hit the perfect frequency, which is 7 Hertz for this setup. So there we go. You start seeing it really nicely. I try to maximize the amplitude, which is right about there. Okay, so now we have node, one belly in the middle. One belly, first mode. First mode is the one at the fundamental frequency, the natural frequency of oscillation of this particular string. If I go at twice that frequency, 14 Hertz, then I see two bellies. That's the second mode. I'm gonna go quickly to 14. And see two big bellies and one node in the middle. This is the second mode, two bellies. Three we've already seen, it's at 21 Hertz, which is precisely 3 times the fundamental, 3 times 7 Hertz, 21, 3 bellies, third mode. Pay attention that I talk about mode of oscillation with M as in Mary, whereas the parts of the string that don't move are called nodes with N as in Nancy. So here we are at the fourth mode at precisely 28 Hertz, 4 times the fundamental, 4 times 7 Hertz. The next one is gonna be a 5 times the fundamental, which is 35 Hertz. I passed, sorry. And there we are. Perfect. That's a maximum amplitude at 35 Hertz. 5 bellies and 4 nodes along the string in between. So node at the very end, node here, 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 and of course at the end, at this near end. Next one is gonna be at 42 Hertz, which is I'm maximizing the amplitude. Oops, I passed. Which is 6 times the fundamental, 6 by 7, 42. This is the frequency displayed. There's an error of 1 Hertz, as you probably figured out by now, on that display. And finally, I'm gonna go to one last mode, which is gonna be a 49 or thereabouts. Try to maximize the amplitude again. Oops, I passed. There's a delay, which is why this system is so finicky. And there we go. At 49 Hertz, I had the 7th mode with 7 bellies and 6 nodes in between, plus the 2 extremes.